collisions. So the collisions are elastic collision, inelastic collision, perfectly inelastic collision, super elastic or explosive collision, and finally head-on collision. So the collision means when two bodies collide with each other. So elastic collision means if there is a no loss of kinetic energy during the collision is called elastic collision. Example, the collision between the subatomic particles and glass balls. Inelastic collision means there is a loss of kinetic energy during a collision is called inelastic collision. That means when the two bodies collide, there is a no loss in kinetic energy between the bodies is called as a elastic collision. If there is a loss in kinetic energy is called inelastic collision. So the characteristics of elastic and inelastic collisions are, so for the both the elastic and inelastic collision, the momentum is conserved and the total energy is also conserved. So what and the kinetic energy is here, elastic collision is conserved and inelastic collision is not conserved. That's why here it is there is a loss in kinetic energy. So you can ask the question, what is the momentum conserved and not conserved, sir? Very simple. The momentum before collision is equal to momentum after collision. So in any collision, the momentum equal to collision and after the collision will be the momentum before the collision and after collision must be equal. For either it may be elastic collision or inelastic collision. So the momentum and the total energy is conserved for both elastic and inelastic collision, but the kinetic energy is conserved only for elastic collision and for inelastic collision it is not conserved. Why it is? Because the kinetic energy is conserved means kinetic energy before collision is equal to kinetic energy after collision, because there is a no loss in kinetic energy in during the elastic collision. So here it is a kinetic energy is not conserved means here the kinetic energy is there is a loss in kinetic energy between the colliding particles during the inelastic collision. So we can say that kinetic energy is not conserved. So here the force is conservative force. Here the force is sometimes conservative or sometimes non-conserved forces. Some or all the forces involved will be non-conserved. So total energy, that is a mechanical energy, is not converted into heat energy and sound energy during this collision. So energy is not converted into heat and sound energy. But here the loss in kinetic energy is there, So that loss in kinetic energy is converted. It will be come out as a heat energy and sound energy. So very simple. The characteristics of elastic and inelastic collision. Both momentum total energy is conserved. Kinetic energy only not conserved for inelastic collision, and for elastic collision it is conserved. So force is conservative and force is non-conservative. Heat and sound energy is not. That means energy is not converted into heat and sound energy. Here the loss in kinetic energy is converted into heat and sound energy. Then, so we are seeing that detail about the elastic collision and inelastic collision. Now we are going to see about perfectly inelastic collision. No, inelastic collision means there is a loss in kinetic energy. If the two bodies stick together after the collision and moves as a single particle or a single body with common velocity is called as a perfectly inelastic collision. So in this collision, momentum is as usual the momentum is conserved, but kinetic energy is not conserved. Kinetic is not conserved means there is a loss in kinetic energy is maximum. So the perfectly inelastic collision means loss in kinetic energy is maximum. After collision, both the body will stick together and move as a one common body with common velocity. Elastic, that is a super elastic or explosive collision. In this collision, there is an increase in kinetic energy. This will be observed in the bursting of crackers. So head-on collision. Head-on collision means that the colliding bodies move along a straight line before and after collision. So the before collision it is coming in straight line. The one body and another body is collide. After collision also it will go in the same x-axis means one same straight line means that is called as a head-on collision. Head-on collision means one-dimensional collision. So the elastic collision, inelastic collision, perfectly inelastic collision, super elastic collision and head-on collision. Now we are going to see detailedly about elastic collision in one dimension. So the elastic collision in one dimension means that is a head-on collision in one dimension. So when a body A with mass m1 and body B with mass m2 moving with the velocities u1 and u2. So the u1 is greater than u2. So u1 is moving faster than u2. Definitely this A will come and collide with the B because both are in same straight line. It will collide. So this is a before collision. During this collision, both will collide. After that, the body A with the mass m1 moving with the velocity v1 and mass m2 moving with the velocity v2. This is the after collision. So, by the conservation of linear momentum, what is the conservation of linear momentum? That is the momentum is conserved means the momentum before collision must be equal to momentum after collision. So, what is the momentum of this body A before collision? M1 U1 and M2 U2 is the second body B. So, we have to add up. That is the total momentum before collision is equal to what is the total momentum after collision? M1 V1 momentum of the A body and momentum of the body B. M2 V2 we have to adopt. So the momentum of the first two bodies before collision, that is A and B body before collision, is equal to momentum of the bodies after collision. So what we have to do that bring the mass M1 this side and mass M2 this side. So M1 U1 minus M1 V1, M2 V2 minus M2 U2. So take M1 commonly outside, M1 U1 minus V1, M2 into V2 minus V1. So this is the conservation of linear momentum. For elastic collision, we can say that the momentum is conserved. Then what is that? Kinetic energy is conserved. So we have taken the by the kinetic energy conservation in elastic collision, though the kinetic energy of the each and every body before collision is equal to kinetic energy of the two bodies after collision. So M1 is a half M1 U1 squared plus half M2 u2 squared, because m1 u1 squared plus m2 u2 squared, which is equal to half m1 v1 squared plus half m2 v2 squared, half m1 v1 squared plus half m2 v2 squared. As usual, the 1 by 2 1 by 2 1 by 2 get cancelled. Then m1 u1, bring the m1 this side and m2 to the right side. So taking the m1 commonly outside, we get u1 squared minus v1 squared, which is equal to m2 into v2 squared minus u2 squared. This is similar to a square minus b square formula. So we can expand as a plus b into a minus b. That is u1 v1 plus u2 u1 v1 plus u1 minus v1. Here v1 plus u2 into v2 minus u2. So that is we have to use the a square minus b square formula. We arrive the equation m1 into u1 plus v1 u2 minus v1. Then m2 into v2 plus u2 plus v2 minus u2. So this is a equation number 3. Already we have a equation number 1 by the conservation of energy. From the one we are derive the equations. The second equation m1 into u1 minus v1, which is equal to m2 into v2 minus u1. Substitute this equation here. That is dividing 3 by 2. So third equation and second equation are we are going to divide that. We arrive this equation. M1 M1 get cancelled. M2 M2 get cancelled. U1 minus V1 U1 minus V1. Then U2 minus V2 minus U2 V2 minus U2 get cancelled. Finally we get U1 plus V1, which is equal to V2 plus U2. Bring the U1 initial velocities to the left side and final velocities to the right side. Then U1 minus U2 is equal to V2 minus V1. This is a relative velocity before collision. This is the relative velocity after collision. So during the elastic collision, one-dimensional case, relative velocity of the approach is equal to relative velocity of the separation. So very simple. By using this equation, we are going to derive the equation for what is the final velocity of the body A and B. What is the equation for V1 and V2? So in this equation 4, you bring this V1 to the left side. That is U1 minus U2 plus V1. Substitute this equation in equation 1. What is the equation 1? Equation 1 is a law of conservation of momentum. M1 U1 plus M2 U2, which is equal to M1 V1 plus M2 V2. So substitute that equation in equation 1. So V2 has to be substituted in this equation. So we are substituted that M1 U1 M2 U2, which is equal to M1 V1 plus M2. Instead of V2, you have to substitute this equation. Bring M2 U1 minus M2 U2 plus M2 v1. So we are getting these things. So next step, we are bring that what are all the things, m1 u1, this is a m1 u1, this is a u1, so you bring this u1 this side, minus m2 u1, this is m2 u2, this is a minus m2 u2, if you bring to the left side 2 m2 u2. So we are getting that u1 into m1 minus m2 plus 2 m2 u2, which is equal to v1 is taken outside, m1 plus m2. So if you bring this m1 plus m2 into the denominator, we get the v1 velocity of the first body after collision. v1 is equal to m1 minus m2 by m1 plus m2 u1 plus 2m2 by m1 plus m2 into u2. So very simple, students. You rearrange these things, we get the equation like this. Then this is m2 u2, m2 u2, 2 m2 u2. Here what will happen? m1 is a common one, you take an outside m1 minus m2. Here the v1 is common one, you are taking the v1 commonly outside m1 plus m2. We arrive the equation v1. Similarly, we can arrive the equation for velocity of the second body v2. Simply we are replacing the interchanging the subscript 1 into 2. So very simple. v1 means v2, m1 minus m2, here m2 minus m1. So what you are going to do, that instead of one place you put 2, instead of 2 place you put 1, here also 2 1, so as usual m1 plus m2. Here the u1, so what you have to do, that instead of 1 you have to substitute 2 as it is same. So here it is a m2, you have to substitute m1. So m1 plus m2 is, if it is interchange, the same as it is addition only, we get the same expression m1 plus m2. Then u2 means u1. So this is a expression for the velocity, a final velocity of the body after collision, that is a body B, second body. So v1 and v2. So this is the velocities of the body after collision. So when the two bodies are having a same mass, m1 and m2 are equal, means what will happen? m1 and m2 are equal. This term will become 0. Then we get m1, that is m2 is m1 and m2 is also m. So 2m by 2m, 2m get cancelled, we arrive only u2. So that is v1 is equal to u2. Similarly, here also this term will become 0, 2m by 2m, 2m get cancelled, we get u1. That is the first body velocity is equal to second body initial velocity, then second body final velocity is equal to first body initial velocity. Then what about when the masses are same as and also the second body velocity is 0? That means the body B is not at all moving, it is at rest. That body A alone moving with the velocity u1. What about the velocities after collision? So very simple, after collision the velocity is v1 is equal to 0 and v2 is equal to u1. Substitute these terms in this equation, you are able to arrive the solutions. v1 is equal to 0, v2 is equal to u1. And similarly, when m1 is less than m2, that is A is a smaller body, B is a bigger body. When a small body come and collide with the bigger body is at rest, because m2 is at rest means, so neglecting m1 in these two equations, we arrive v1 is equal to minus u1 and v2 is approximately equal to 0. So the final body will become 0, because this body is bigger body. When the small body come and hit on it, the bigger body never moves. So the smaller body velocity is equal but opposite direction to the initial velocity. When m1 is greater than m2, when a bigger body come and collide with the smaller body, when that smaller body is 0, it is at rest, velocity is 0. Neglecting m2, we get v1 is equal to minus u1, then v2 is equal to 2 times of u1. So these are all the special cases. You should remember, this may be asked in problems point of view. So what is the question? We are seeing that the question is elastic collision in one dimension case. You take draw the diagram, conservation of momentum, kinetic energy conservation, then rearranging this, we can get that the relative velocity of before collision is equal to relative velocity after collision. By using this equation, we arrive the expression for velocities, final velocities of the two bodies after collision. And there is a special cases when the masses are same, then the masses are same with the second body is at rest, then first body is a smaller body, second body is a bigger body, then second body is a smaller body, and first body is a bigger one. These are all the cases these are seen that. Okay, thank you students.